Yeah, it goes simply.
Find a spot on the whiteboard.
Yeah.
Dylan, let's go. Grab us a pen.
How did we do the last one?
What happened?
You run around there and grab that? Actually, there's a rope around there. Wow.
Okay, well, strong base should be anything like
There we go. There we are.
Isn't it a highlighter?
What are we even doing? Oh, strong base. Why is there no space? Is there no?
It's not very readable, is it?
oh no, it's
Can I borrow that marker?
what makes
I just need a marker. I'm gonna leave. I'm gonna move to another
I didn't know it was supposed to be a reaction. I thought it was just.
There's more space.
Oh, it is.
Yeah, fine. Maybe I will do that.
I don't know.
Oh wait, let's do it. You. Yeah. Then you can't play Among Us in the back of the class. I don't do that. You do that. Really? What's on your iPad? Let's see Among Us.
No. Are we base?
You do that.
what makes
Oh,
OH.
strong base. What?
What makes OH.
Oh,
you're right. Meaning you can use the word.
So you can do
Goes to H plus.
you can do O2 minus and H.
Now, absolutely do not forget your charges. Why do we have people sitting down? Why are you sitting down? No, you're not. I just saw you running in here with Dylan at the tutorial.
That was Sophia.
H plus.
No, that was you.
Oh, that was
H
you.
plus. That was
Yeah, that was
I didn't remember the H tutorial.
We did. We were singing Taylor Swift.
Always minus no. Because always minus, oh, you have it backwards.
Yeah.
That's odd. Reactor should be on the left. Oh, no, you have to look at that. I'm not gonna tell you the answer. H1, nice try, but you have to react it with water. I know.
Okay, so do
Must react it with water. Ooh, you guys are in a good.
O plus.
First one, just don't forget your charges. You're on a good path. Yep.
Oh wait. Oh wait.
You're missing a charge on one of them.
Wait, 2 OH.
Oh, there we go.
There you go.
With the negative charge of 1.
Good. Whoa. Yes. Good. Yep.
Is this good?
Yeah. Yeah. Keep going.
NH2.
And then once you have the strong bases down,
Goes to NH2.
ah,
OH.
I tried to write on the board.
NH2 is negative 1 charge and OH is negative 1 charge.
Hey. What he did. I stole my laptop. I ran away with it.
And H plus H arrow.
Came into the room yesterday and told you that you had his laptop.
I did.
Like H plus. You got one there, and that's
Yeah, and then H3O plus.
Next
five.
one.
Now there's six. How do we just magically?
Oh,
Yeah.
He actually stole my I'm gonna like have to carry the laptop all the way from the phone.
Once you've done your strong bases, do some weak bases. Do at least 6. 6 weak bases.
H2O.
Why do you have H2 plus? You're just taking the base and you're reacting it with water. You've invented.
The base is N83. React. Get rid of this. Get rid of this.
Where,
We don't need
where, okay, on top here, where's your
This
strongest
arrow can be whatever it wants to be.
Why?
There, they're the opposite side of one.
What?
Where's your
Do you
strongest?
want this arrow because you're fancy?
Right, which one of these is strongest? Where does it say which negative is strongest? No, that says it cannot be an acid, because it's the opposite side of one arrow. Where's the bases of it? No.
Okay, it'll be
Which side is labeled base?
H
That means you're only two.
plus OH.
Oh,
And then
two.
H
Minus
four.
There you go, you have to get water. Which you started. Though you have done something, the second one's product. Check with other people. Eshwan, why are you reacting H plus with water? I said weak bases. Is H plus a weak base?
Come on, Eric.
What's that guy rocking in the water?
Wait, I said
That's for.
There you go. That's better.
You said what?
You got your weak ones going. Yeah, you guys are doing, yeah, excellent. You guys are on fire.
How to just more high this is so confusing. No, G-O plus H2O. We're gonna go OH plus OH.
Actual H?
No, that doesn't make any sense. Two OHs. No.
Yep.
Thoughts? Opinions? Thoughts? Concerns? Questions?
SO4 2 minus plus H2O.
Good.
Then H.
However,
I don't know which you added
You should-
one, but it came out of one.
actually, a lot of them are actually fine.
Plus OH.
There's one in there in which you've done something weird with the charge. You forgot to get rid of a charge you should have. Second one down.
I'm like, okay, you better fix it. I'm gonna block you. That's basically
Two more.
That was a good.
H.
I removed the.
Yeah, no, you're good. Yeah, yeah, fantastic.
H2 204. The negative 1 charge. Plus H2O goes to.
Oh, and your arrows are wrong.
Do they just need to be normal?
Yeah, they just need to be all about.
Oh, you can do it? Okay.
Or I'll
OH.
probably won't be able to do much, but.
One more?
Okay.
Okay, ready?
Yep.
H2 C6 H5O7.
H2C6H5O7.
With a negative 1 charge. Plus
Wait,
H2O.
this to this.
Teddy?
We're gonna get
What was your favorite weak base out of there?
my favorite blue base.
H3
SO3
Dylan,
C6
shut up.
minus
You
2.
shut up.
And A, what's your favorite weak base?
C6.
H5
What's your favorite weak base?
O7.
C204, what's the charge?
Minus 2.
Minus 2. And
Yo.
they're still working.
Okay.
Taylor, what was your favorite weak base?
I think H2 C6 H5 and O7
Probably.
Minus.
minus 1, yeah.
Okay, that's an annoying one.
Weak bases.
Yeah.
Okay, give me some.
Big big.
H plus.
Why?
Oh, we still donate to this.
Plus OH.
You know that film project that I was doing for
Next one. You write it. You said
He's not.
Okay,
Just kind of like.
Luca, put away laptop. You check your results.
Those are nice pants, baby.
Well done. Bye, everybody. The strong bases, there can only be two possibilities, but there is a secret third possibility. What other reaction do you know of gives off hydroxide with a one-way arrow and does it so at 100%?
Wait, no, weeks are. I sort of like 2 a.m. You got
NaOH.
no, no, it's
Now, this is technically not, Luca? This is technically not in acid bases as a reaction. What unit did we do this in?
solubility.
Solubility. So, if we have a hydroxide, a metal hydroxide, they're often considered strong bases because they give it off at 100% if they're soluble. And it depends on how much they're soluble, and we would actually work more with solubility than you would. But it is technically, and it is, according to Arrhenius, which was the first definition of acid and bases, it is a strong base. So all these are the only ones on table. These also exist, and I keep re-emphasizing it because once we start doing a lot of weak and strong acids and bases, sometimes students forget the grade 10 strong bases, and those are still around and they still work. Weak base, main difference, now we have two-way arrows. It is an equilibrium, whereas up here it is not an equilibrium. We donate the hydrogen, it comes off, makes hydroxide. Double check your charges. So I always look at my charges at the end, I go over here and I go, oh, that's -2. Therefore this has to come out to -2. And that way if I forget to put a charge on one of them, I instantly see it.
get it wrong.
Double check your charges as you're going through because OH
Why is it NaOH?
and OH minus are two entirely different species. They are not the same compound. And so in chemistry, it's not just a spelling mistake, it actually, you've changed fundamentally what it is. Now a couple,
Can you do that?
yep, I will, but I'm just gonna show something else, are tempted when they're looking at bases, you see this here and go, oh, that's down in the strong bases. It is not. Which side is this on?
Weak acids.
It's, yeah, this is a weak acid. In fact, this acid is so weak, can this ever act as an acid? That arrow only goes one way, so it only goes this way, it can never go backwards. So this is telling you that hydroxide can never be an acid. This is not putting it on the acid side, it's not even telling you it's on the base. Notice as well, although H plus is here and hydroxide is there, every time we're writing, when we're making a base, what is the common product that keeps coming on? OH minus. So although they're not hydroxide donors, every proton acceptor creates hydroxide. That is why it is the fundamental base. So whenever you see it on your table, although it says base on this side, it is only referring to these things. These are obviously not bases. This is pure acid. And in the same way, that is not referring to that one as a weak base of any kind. That is just because when water splits, it makes the ultimate acid and the ultimate base. And so it's just a product of that particular reaction of water. So don't consider those as part of the definition of this page. They're there for convenience because we're going to use this result a lot. Oops. All the way back.
Yeah.
Questions about writing the formula about either acids or bases?
Wait,
Dylan, you said wait.
wait, no, I was just gonna copy down the weak base.
Sure. Then some people ask me to go back. Does anyone need to copy one down? They're all around the boards around you as well.
2 minus. Oh, did you just take every single one from the?
Do you have more tissue somewhere?
There's a box there. Is that box empty?
Yeah.
Weak base.
Check the back on the desk, and if there's none on the
Oh, yeah, I
desk,
see the-
in the cupboard, I keep extras. Oh, perfect.
Plus storage. What are those like bracket things on top? What does that mean?
This, that was just showing that this whole side was -2,
Oh,
and then this side is -2.
okay.
Okay? Are you good?
Yeah.
Okay. This is just getting used to our table. So compare the relative strengths of acids or base. I'm going to take out your table right now. We're going to go over it, and then I'll just summarize it on here. So I'll just use this space for that. So bring up this table. Where are all the strong acids? Top which side?
Left side.
Left side, and how many of them are there?
6.
6. So only those here? If it wasn't shaded, how would you know?
One-way arrow.
One-way arrow. So we see a one-way arrow. Those are the strong. Now, these ones, as bases, are only bases in a technical sense. They are the conjugate bases to a strong acid. Can they ever accept that proton? No. So these are the weakest of all bases, in that they don't react at all. So those are our strong acids. And then, since I highlighted this twice, where are our strong bases? Bottom, right. It is labeled on the top, base and acid. It even tells you strong and strong, ignoring this reaction, because that's the water reaction that we will end up using quite a lot. We just consider our table of all the weak acids and bases. What is the strongest weak acid?
What?
The strongest weak acid. HiO3. 1.7 times 10 to the minus 1.17. It's actually got a fair amount on the reactant side, so quite a lot of it ends up here. What is the strongest of the weak bases?
Monohydrogen phosphate ion.
No.
Oh wait, sorry, PO4 minus 3.
Yeah, phosphate ion. So switch sides. So
Yeah.
these are the bases. These are the strong weak bases.
How do
And
we know
these
those
are the strong weak acids. And they give you a table and arrows on either side to remind you of it. So that's how your table works.
Wait, but how do you know it like cuts off there and not the one above?
Some reactions, this reaction
Yeah.
is fundamentally important to acid-base chemistry, because the reason things are acidic is it all revolves around this reaction. So at an acid, what you're doing is you're causing that concentration to go up, and according to Le Chatelier's principle, that concentration goes down. And so this is the reaction that all the other ones revolve around. Water is both an acid and a base.
Okay.
And then this is, remember when I told you that H3O plus
Yeah.
is acid? In a way, this is a reminder of that, because this is just saying that those are equivalent.
Okay.
Okay? Okay. So, to summarize, let's see if my writing's neater or messier on this. Top 6, left, strong acids, arrows point reaction. Bottom to right. Strong bases. Arrows. Left. 100% reaction. Many strong bases are not on the table. And that's because there's solubility equations. So weak acids on the left, weak bases on the right, and we can judge those by the fact that they have equilibrium arrows. They're two-way arrows, and we're very soon-ish going to start introducing things like Ka and their equilibrium constant. I went too quick. Anybody still ready?
Yes.
Okay, never mind. I think I can write faster when I'm sitting down.
I'm just writing lost.
Okay.
I'm not on the list.
Okay. Explain, and it's a fairly simple explanation, why the strongest acid in aqueous solution is H3O plus and the strongest base is OH minus. If you have any acid and you react it with water, what do you get?
You get
H3O plus.
H3O plus and
X.
in this case X minus.
Why'd you put HX?
X is just generic. Any acid is HX. All acids make H3O plus. The concentration of the acid acids that dissociate 100% to make 100% H3O plus are our strongest acids. And so H3O plus is what acid is. The strongest acid that you could ever have in solution would be pure H3O+. It's because that's what it is. It's a bit like saying, why is money worth more than like gold or silver or anything else? It's because money is the unit by which we measure it in. All those other things are worth money, but money is money. Acids, all acids generate H3O+, so H3O+ is the strongest acid. We are all using things to generate that. Similarly for bases, if we have a base, B plus H2O, what products do I get from that?
H plus OH.
OH minus plus
B plus. BH
close
plus.
BH plus. Yeah. This would be very similar to NH3. I know this one is much more self-explanatory. I think you've seen that type of reaction a lot more, but if this is like NH3 plus H2O. This is actually equilibrium, goes to OH minus plus NH4 plus. That is the same reaction. If it was B minus, then you get OH minus and BH. Similarly, all bases produce hydroxide.
What's more dangerous, the strongest base or the strongest acid?
I would, for a living creature, probably base.
Really?
Bases,
all bases produce OH, is that what it says?
all bases produce hydroxide, yeah. The stronger the base, the more hydroxide. It is, again, what we measure. Your body is always a little acidic, and you have a lot of reactions to deal with a small amount of acidity, whereas a base touches you and it turns your fat straight into soap. Like, it just starts breaking things down. So bases are fairly bad.
So
That being said, someone has taken that knowledge and run away with it and said, we can classify all food into acidic or basic, and some foods are bad for you and some foods are good for you. None of that is true, because when you eat things and it goes into your stomach, what does it become?
nutrient.
Neutral? No.
Acid.
Acid. You make hydrochloric acid. You acidify everything. By the time it gets to your small intestine, you have to neutralize it and make it normal. If you could affect your blood pH by eating food, you would die. Because the amount that if you change your blood pH too much, you just go into a coma. Your blood pH is very tightly regulated by your kidneys. You're allowed a little bit of variation, but it's considered dangerous. One of the dangers of doing something like those really high protein diets, and you're burning a lot of protein for energy, you have to do something with all the ketone bodies that come off from that, because it's not sugar. So you have a lot of extra waste chemicals. If you smell acetone on someone's breath, they put themselves in ketosis, in which they're actually making a lot of ketone bodies. That can generate a lot of acid in your blood, and you actually can die from that if it goes too far. People who are really intense about high protein diets will sometimes get ketosis tabs to test their saliva and see how close they're getting. Not necessarily a healthy state to be in if you're that much ketosis, and that is one of the few ways you can, through your food, affect your blood pH. But just eating regular food. Now, that being said, a lot of the diets still work, because mysteriously, chocolate bars and cheeseburgers and all these foods that any dietitian would say you probably should have that in lower amounts are considered forbidden under their acidic basic criteria. And all the healthy foods, except for grapes, weirdly, are considered, oh, those are the good kinds. So they still are just doing regular diet stuff half the time, but weird things can be put on either side.
They don't consider grapes as healthy.
No. A lot of really health conscious people don't like grapes because another thing they get associated with is sprayed by pesticides. And so they just don't generally want to eat them. Just rinse your grapes under water, you'll be fine.
But what about people who are like on a keto diet where they just stop eating carbs in
Yeah, if you stop eating carbs entirely, that if you go into full ketosis, and you can acidify your blood. It takes a lot of work to get there. Most people aren't as low carb as they think they are. There's a lot of carbs in a lot of things. But if you are really good about counting your carbs and you get yourself down to 0 carbs, you could put your body into a really bad metabolic state. Now, the keto diet was originally invented for people who undergo seizures, and we still really don't know why. But if they keep their carb count really low, it can make the seizures, especially seizures that are uncontrolled by medication, so it doesn't matter what medicine you take, you still get seizures, they just go away. And so it was invented, and it's particularly bad during childhood. So it was invented for children. They don't make them have 0 carbs, they just lower their carbs. So there are safe keto diets you can do that are made for that. In terms of using them to diet, they will cause you to lose a lot of water mass really quickly, which usually gets people feeling very pleased about themselves. But you've only lost water mass. After that, it's just calories in, calories out. People who are on an all high protein diet or any really extreme diet are just restricting calories. If you calculate how many calories you're eating, if they eat over their metabolism, they're going to not lose, and if they eat under. If you really limit the amount of foods you can eat, it's difficult to eat enough calories. That's all it is. There's no particular value in it above that, other than it's really good at creating eating disorders. Most really restrictive diets are very good at creating eating disorders. So you have to be careful with those. Okay, 8. Sorry. And that being said, if you've just tried a keto diet or something, I'm not saying you have an eating disorder or that you can't try these different things, but just a lot of health people have a vested interest in you buying their book or supplement or anything, and it's a very big market. Consult with a doctor if they think that this would be worthwhile. I do miss Mr. Emile, who was very well trained in biochemistry and was a coach, and because a lot of the grade 9s who are making protein mixes are not doing anything that is worthwhile. They are just eating extra food. Okay, strength. Predict whether products or reactants are favored in an acid-base equilibrium. A strength is considered the extent of its ionization.
What does that say,
Yep.
sorry? Exert,
Extent. Extent, yeah, see?
of its ionization, okay,
Yeah, see? Oh, it got it. I win.
Start tallying how often it went.
So, for this example, I won't have you go to do it on the whiteboard, but I would like you to write out the reaction of CH3, COOH, so acetic acid, plus H2 BO3 minus. What are the products going to be? Well, first identify what is the problem with me writing those two things? Good.
Which one?
Back to it. Ooh. I have buttons. And that one just makes that. If you're to predict the products, what do you need to know?
Acid and base.
Which one's the acid? Which one's the base? Which one's the acid?
The CH3.
Could the other one be the acid?
Potentially.
Potentially. Now, I'm actually cheated because can CH3COOH ever be a base? No, it is only an acid. You won't find it on both sides of the table. But H2BO3 you could find because it could give up those H's, and you could give up, or it could donate those H's. If you're looking for something, CH3COOH, where is it? CH3, there we go. And where's my H2BO3? Does anybody find that one?
It's on the.
Oh, it's in the bottom there.
It's next to the ammonium ion, or above it.
H2BO3, yeah. Now can we find it on this side?
No.
Yes.
No.
No,
What?
it should be. I guess they said I'll use a different example.
I see H3 of BO3.
Yeah, I'm looking for that one, because theoretically it could lose another hydrogen.
How
But-
do you know this?
We can't find it. Oh well, my next example will use an amphiprotic one. That's fine for this time. Because this one has to be the acid. That makes this one the
Base.
base. So now write their two conjugates on the other side.
So it's not amphiprotic?
H2BO3 is amphiprotic, but they don't have it on the table, so I can't illustrate the point I wanted to make.
So how do you know it's amphiprotic when it's not written on the table?
It's got a hydrogen that it can give away, and it's got a negative charge to attract a proton.
Oh, I see.
And that's borate that you add to your laundry.
So would it be acid, base, base, acid?
Hmm?
I mean, depends
You
on
had,
where
like, your CH3COO would be your base, right?
Yeah, that would be your base. So on this side, you get CH3, as you said, COO. Finish that off. Taylor, you missed the last word there that's bothering you. Nope, minus. There you go.
Yeah.
So
And then it becomes
this
H3.
becomes the base. What's the conjugate acid that it made?
H3.
H3.
H3 BO3.
BO.
VO?
3.
3. There we go.
Oh.
And then that becomes the acid. And we have our acid-base pairs. Now we compare, this is an equilibrium. Which side is favored? As in, where will we find most of the stuff? Will we find it on the right, or we find it on the left? Quickest way to do that, we have an acid, and we have an acid. Which is the stronger acid?
A.
The one on the left.
The one on the right.
The one on the left.
What is the, for that acid, and now we have this acid, we can just compare relatively. Which one's stronger?
Left.
Left.
Oh.
That's the stronger acid. It's the stronger of the weak. Now, we could also use numbers. We could say it goes 1.8 times 10 to the minus 5. This is 7.3 times 10 to the minus 10. But we're not even doing numbers yet. We're just comparing relatively. This is the stronger acid. So you pop back, and you go stronger. If this one's stronger, where is most of the stuff?
On the products.
On the products. That means it goes this way more than that way. So if you have a stronger weak acid on the reactant side, then the products are favored.
But we still write it in equilibrium.
Yep, it's still an equilibrium, you just have more stuff on the right. Because this one, the acids are trying to donate a proton, and this is better at donating a proton. So it has passed the ball to the other side, and they sit over on that side.
Oh.
It's remember when we did our wall of chemistry, and we chucked things back and forth? The side that was really good had the least amount of ammo, because they could chuck it back the fastest.
Yeah.
So this is similar to that.
So
The
this
stronger
is-
acid, everything's on the opposite side.
So it favors the other side.
It favors the other side.
So the right side.
Yeah.
I thought it was not gonna make us
So-
all on top of the tables.
What I'm saying here, what does WA and WB stand for? Weak acid, weak base. The weakest side is favored because the stronger side is pushing it that way. If you have a strong acid or a strong base, obviously the products will always be favored because it's a one-way arrow.
Wait, what if there's a weak acid on one side and a weak base on the other side? would that just be equivalent?
Sorry, what? Say it again?
Is it possible to have like one weak acid on one side and a weak base on the other side?
That's what we have here.
Possible?
We have a weak acid and we have a weak base on the other side. Its own weak base. Because an acid-base reaction has to have an acid with a base react.
No, but
Also, if there's a weak acid and a strong base on one side, and a
Oh.
strong acid and a weak base on the other side.
If
yeah.
you can't. You cannot have something that's strong on the product side. They're one-way arrows. Right?
Wait, you can't have something strong.
Like let's say, to take your idea, because
So no matter what.
nobody has ever asked that question before. So let's say we have HCl, strong acid, right?
Okay.
And it goes to plus H2O, goes to H3O plus Cl minus, right? And that is a one-way arrow. That can't go back. HNO3 goes to H plus NO3 minus. I'm going to do it in the simple form so I don't have to write the H plus, right? One-way arrow.
Yeah.
So what happens when you get NO3 minus plus HCl? Do you get HNO3 plus Cl minus? No. You get H plus NO3 minus plus Cl minus. It is 100% soluble. It does not come together. All that happens is this does its own thing and this is ignored. NO3 is just a spectator ion. You cannot have a strong on both sides. So you cannot generate a strong acid that way.
Oh.
Was that your question?
Yeah.
Okay, considering this, oh, yeah, let's start. Yeah,
Put on the Kahoot music again.
music,
What
sure.
is this?
What is this thing called?
Go. HelloSmart.com. Code is 897683. HelloSmart.com. And
Some of those questions we never even talked about.
yeah.
What's it called? Hello Smart?
Yep. What is I'm not entirely sure I have the speakers properly hooked up, so what? I wanted to give you music.
What's the class ID?
897683. Oh, apparently you're gonna see Kahoot
What's
music.
the ID?
What does it mean, favors tea?
HelloSmart.com.
Ooh. Yeah,
What does it mean by favors tea?
favors tea.
That's not the put your
Following
phone.
reactions favors tea.
What you're talking about?
Oh, it just cut it off because of how it's set up.
Oh, okay.
This is the formation of products.
And why isn't it coming through the big speakers? This is silly. There we go. This is Kahoot reggae music. How about
Okay. Do the other one. Drop
Can we actually do
no? Kahoots are dumb and fun.
Why do we use this off-brand version?
Fine. Original soundtrack.
which one?
to the reggae.
Nah, do the remix.
Reggae's the best.
Oh, there's apparently a back to school funk edition.
It was not.
Look at it.
Disco. we're just sticking with the 80s. The music of my youth. Come on, only 42% of you? Let's go. And hey, you done? Okay.
I think I got it.
Oh, I'm gonna tell you.
Yeah, I think that one.
HelloSmart.com. Just type it in. No, you didn't type in HelloSmart. Because it fills in as HelloSmart. There you go. And type in 897683. Give yourself any kind of name. Finish it. Come on, finish it. Are we answering the question? What? Answer questions. Oh, this is the fantasy edition.
What other editions are there?
Okay. This isn't actually good music for that.
This is great. What other ones are there?
Let's do the regular OG.
There we go. Come on, 80%. Last 20%. Let's go.
Turn it off, I can't hear it.
Faster. Where's the playlist?
What else?
Yeah, we're gonna start with that.
Look, why is it not playing anymore?
Because you turned the sound off.
Did I turn it completely
Yeah,
off?
we like watched you.
Or not.
What's this?
Oh, there we go.
Is that geometry dash?
Play Quizlet music.
Play what?
Quizlet music.
What's Quizlet music?
No.
That's off-brand Cahoots.
And what is this? Off-brand.
No, I was playing video game music.
Oh.
That was from Doom.
Mr. Newfeld, have you played Doom before?
Doom?
Yeah.
Yeah?
Like
Like
the
the
newer,
original?
not the original.
Well, if you haven't played the original, have you really lived?
Yeah.
Yep. Okay, 93%. I think we've done enough. 5. Submit your answers. 4, 3, 2.
Hold on,
One.
hold on.
What's it
Okay, you submitted. Okay.
Go.
Yeah.
End.
Oh!
Nice.
Yeah!
So, you should get results.
Yeah! Look at us.
Which one of these favors the formation of products? M?
Say,
In all of these, what are you comparing?
oh, which side is
You're just looking at the acid, which one's higher up. So HNO2 is higher than HF. In all these other cases, it is not. Let's check the next one. There it is. No, come on. Click. For B, oh, we got a lot more variation for this one. Which of the following are the oh, hold it. When I go back, which of the when it says which is favors the formation of products, where does the weakest one have to be? On the product or the reactant side? Product side. Okay. So on this one, if the reactants are favored, where does the weakest one have to be? Reactants. So HCO3 minus 1 versus, H2S versus H2CO3. All the other ones will have them on the product side. Questions? One that you think is absolutely different? Eric, question?
No.
What are you doing? An A? Stop that, put that away. Okay, last one. Or second to last one. Compare the relatively. Got everybody back, Eric? Compare the relative concentrations of H3O plus or OH minus between two acids or two bases using their positions in the table. Which of the following will have the lowest concentration of OH minus? So what kind of base are we picking? Now, why do I have sodium in front of all of these?
Dissolves.
So it dissolves, and why can't I just write F minus?
I'm so hungry.
Pardon?
It's together.
They are together. Could I write F minus? Yeah, I could. I could have written these all as F minus, Cl minus, HCO3 minus, HPO4 minus 2. But as a reminder, if I pull these off the shelves, they have to be with something. So this
It's soluble with
and F minus are the same for all your purposes.
because NA is soluble.
So you should, yeah, Na is just a spectator ion. So, start this one. Go. Apparently I'm playing.
Why is there another one?
There's another one.
Stop it.
Go.
3 questions.
Yep. Oh, well, before you do that, by the way, this one should be easy. Which one of these is the weakest base? HPO4 minus, HCO3, Cl minus, or F minus? No. It's pretty weak, but not the weakest. Is there any one that's higher up than F minus?
What?
Because a reminder,
Same.
it goes weaker the higher up you go. Is there any one of those that is so weak
Wait,
it's
so the
0?
weaker the spectator. Wait, what? Wait,
What's weaker than F minus?
weaker than F minus?
So where's F?
Weaker than F
There's
minus.
F minus.
Wait, where's F minus? Oh.
But we also have Cl minus, HCO3 minus 1, HPO4 minus 2.
HPO.
Well, Cl minus is a lot stronger.
Cl minus is a lot stronger?
Wait, no, weaker. Wait,
Weaker.
Yeah.
Cl minus is so weak, it's not even a base.
Yeah.
It's a spectator
Well, I was
ion.
thinking the acid side.
So this one is the weakest one.
So that'll make the concentration.
So that'll have the lowest concentration of hydroxide because it won't generate any hydroxide.
So, so if you want the highest concentration of say H3O, you would want the strongest acid.
Yes,
Okay.
Wait, so the lowest concentration of H3O, you want the strongest acid?
yes.
If you want
So,
the highest, you want the lowest. Okay.
yep, go. Now do those. Do we want music again?
Yes.
You need to be salty.
What's it called again?
Give me a random word.
Bob.
Bob. Sabine, another random word. Zebra. Zebra, nice. Okay, we get Zebra Man.
6.
Is this on Spotify?
Yeah.
Yeah.
Can you turn it on a bit?
Did you get some
Zebra Man by Bob James. Shout out.
Can you play whatever songs you want for this?
Yeah, because I have Spotify.
Play Love and Jeopardy.
Did you
No, I kind of like Zebra Man
I
now.
like Zebra
It's
Man.
like this.
I'm going with Zebra Man.
Mr. Newfeld.
We played Lana Del Rey last year.
No.
Pardon?
No.
No, why?
No.
I'm gonna get so copyright struck. That's true. Oh, the saxophone? So people can hear words. And
End.
check your answers.
Oh wait, no, I got it right.
Fair number, well done. 6. But half of you picked B.
Fuck, oh, not me.
Wrong again? I only got one right.
No.
Yeah.
Now-
What was the answer for the second?
I got A, you got D. We were both wrong.
Which one of these is not like the others?
That was so bad.
Which one of these is just
Oh, we should
not
have
the
gotten
same?
that. That's
Dylan,
Hey.
why is this one the only right answer?
Well, because we want to choose the lowest acid or like the weakest acid.
What kind of, no, highest concentration of
Sorry.
H2O+.
Sorry.
Acid,
The
and
weakest.
it's
It-
the only one that goes like fully
Yeah.
acid.
This is 100%. 100%. That one could do 3 acids, but it doesn't go 100%, so it'll never be close. That one goes 100%. Next one. Ooh, most of you picked D. Am I wrong? Which will have the lowest concentration of hydroxide?
And the weakest.
So we are picking the weakest base. That's a base. That's a base. And that is all. These are all real bases on your table that will work. But nitrate is the opposite of a strong acid. So it cannot even act as a base, so it will produce no hydroxide. So this is the lowest concentration of hydroxide. I think some of you might have been picking the strongest base.
Yeah, I tried to go for the strongest.
Yeah, but we wanted the lowest hydroxide. Lowest hydroxide.
Wait, but isn't SO?
Wait, but if we want the lowest, we want the highest. So the highest.
SO4 is just one under NO3.
No,
I-
high makes more.
I want the lowest amount of base. How would
Oh.
you create
The
the
weakest
lowest
base
amount
of
of
base.
base?
So-
Oh, okay, okay.
So if I go to,
I was confused.
so here,
Yeah.
the bases get weaker as you go up.
Exactly.
So that one was right there.
I think I got the
Okay.
answer.
And
What about my last question?
I'm kidding, it had to go show the table.
No.
Come on, come on. Oh, it went off the page. Okay, go away. And last one. Ooh, most people got that one right. Which of the following have the highest hydroxide? So this one is picking the strongest base. It's the one that's the furthest down on the right hand side. That would be PO4. Nitrate is really high up. Now some of you picked B, which is CN minus. So let's CN minus versus PO4. PO4 is all the way down here. CN minus is there. So PO4 further down, a little bit stronger. For those who picked the other ones, does that make sense? Okay. And last bit. Which of the following are amphiprotic? Please pick. And which of the following reactions is water behaving as an acid? Please pick. This one doesn't have a fancy app. I'm just gonna. Which of these are amphiprotic? We already did this in an earlier learning outcome. It's just duplicated in this section. Tell me when you're ready.
I look so hungry.
You can't be. It's less.
You were like 10 minutes from lunch. Or no, I lied. 20.
20 minutes.
But we can just minus 10. Like cut it down.
I found HPO4.
HPO4 and
Okay,
H2O4.
it's just PO4 and HPO4.
Well, that thing says. Oh wait, no, it's broken. That clock's broken. 10 minutes. I lied.
It is 105.
Okay.
This one. Can this be amphiprotic?
Yes.
Why?
What? No, it can't be. It can't be. It's not.
It can't be.
Okay, Eshwan, why can't it be? Can it act as a base?
Yeah.
I
Can
think
it act
there
as
were
an
3
acid?
antiprotic.
Why not?
Because it's PO4. Like it can't go that way.
Can't give.
Why not?
Because it's too strong.
Why can't it give a proton?
Because it's too minus.
It ain't got no.
You keep saying words, but the
Okay,
don't.
like it doesn't have anything.
There you
can't
go.
just-
Yes, yes. It doesn't have any. That's
Oh.
yeah. That's what I'm going for. Because when you say it can't, I'm like, well, but why?
Oh yeah, okay.
Since you just guessed, I'm going to ask you again, Ashwan. Could this one be amphiprotic?
No.
Why not?
It can't do it.
Why not?
Because it doesn't have it.
It doesn't have what?
Protons.
It doesn't?
Like,
It has a hydrogen.
oh, it has a hydrogen.
It has a hydrogen.
It does.
It works.
Yeah.
It works.
Also, it will be.
Yeah.
Oh, wow.
Can that accept a hydrogen?
Yeah.
Yeah. So you can go plus H plus, and you can get H2PO4 minus, and you can go off of that and get PO4 minus 3 plus H plus. So this definitely can be amphiprotic.
Yeah.
Okay.
The next one is like.
Next one?
Yes, that's
Dylan?
product.
Is that amphiprotic?
Because you can get rid of the hydrogen, it'll be HPO4, just neutral.
Yeah.
Or it
Minus
can-
2.
Or yeah, sorry,
Yeah.
-2.
Or
Or it can accept a hydrogen. Wait,
Yes.
yeah, accept a hydrogen. It'll be H3PO4.
right. Can this one be amphiprotic?
No.
No.
No. Highly unlikely. If it doesn't have a negative charge, getting H4PO4 plus 1, really unusual. The only one you know of that does that is NH3. Down below,
Check on your chart if it has both.
yeah, and your chart should have it on both sides, which is the other way of checking. For the next one, in which of these is water behaving as an acid? What is a Bronsted-Lowry acid?
An acid base that has both conjugate, or it has conjugate acid and bases. Hold up.
What is Bronsted-Lowry?
He's a umbrella.
Yeah, what does Bronsted-Lowry acids and bases do?
OH.
Nope, that's Arrhenius.
That's what I meant.
Conjugated base and acid
They do have that. What do they differ by?
By H.
By
and
H.
By
So if you're a Bronsted-Lowry acid, what are you doing with your hydrogen? Are you accepting it or giving it away?
Giving it away.
Giving it away. In which of these is water giving hydrogen away? Is water giving hydrogen away in this one?
No.
No, in fact, this isn't even an acid-base reaction. That's stupid. It's decomposition. Is water acting as an acid or a base in here?
Base.
Base. It's accepting a proton. Is water acting as an acid or a base in here? Acid. So whenever you have a base, water has to be the acid to generate hydroxide. What is water doing here? Base. It's accepting it. So the one that's behaving as a Bronsted-Lowry acid is that one.
If it was asking for a Bronsted-Lowry base, then it would be the other two.
If it was base, it would be,
Wait.
yeah, these two.
NH3 plus H2O. H2O is the acid.
This is acting as an acid
Yeah.
because that is acting as a base. Now, you have the rest of the class to, wherever you would like to, work on your Hebden. Wherever you would like to.
Okay, in my mind.
Oh.
We'll discuss that.
I have a question.
We will discuss it.
I know.
Oh, I didn't tell you about your mark.
Yeah.
Yeah, tell us.
Next day, I'm hoping to get a set up of a sheet of paper. It's going to have your exam, your test mark, your communication, your critical analysis, your reaction kinetics, your equilibrium, and your cell mobility, all for the test, and a rough draft of your report for you to look over.
So, will it have our like overall category?
Can I know what I got?
Yeah.
Sounds so
Yeah,
good.
so, and,
Let's go eat.
yeah, we'll do.
Thanks,
If you didn't do well, it's one test out of three. If you did well, it could possibly be more.
So it's not like.
It doesn't like totally. It's 1 out of 3, whatever it averages up to.
I came across something on the internet and I wonder if it's true. In the comments of an Instagram, someone put that the entire recipe for
Oh,
Is this real?
I don't know this.
Does it look real?
We're gonna
So
go
it would be
on.
really funny if it
Wow.
was.
Do I decide? Were they happy? Oh, it's real enough that I wouldn't be able to tell it wasn't real at this point.
That's quite funny.
Is it the one bottle method?
Hold on.
I don't know.
Oh yeah,
Clear
the one
bottle.
bottle method. That's my You
Yes,
run
I-
that.
No, like a meth head.
Is
You
this
used,
your
you used to
song?
need
Is
you used
this
to need 2 bottles. I don't think so. You used to need 2 bottles, like you'd have to move stuff, and then somebody invented the 1 bottle method. You need 1 pop bottle. There's a high risk it'll blow up in your face and spray
Yeah.
you with acid.
I don't know. I just thought that was funny, and I thought you'd
Yeah.
think that's funny.
Yeah,
What else? Okay,
yeah.
I don't remember.
It looks real.
There's this
Yeah.
there's this sound on TikTok. Can you find it for me actually? It's like
Oh,
there's that one, but it's like in French, so that's why I'm just saying it. But people are like, oh, me when I don't like someone, they ask me to make a drink, and they're like mixing random things in the bathroom. But I think someone.
Oh, I saw that one.
I think I sent you that. Did I send you that?
Yeah, I think she was joking, but if anybody ever saw that and did that, oh my god.
No, lots of people. That's like a trend. Like lots. I've watched multiple people who did pour things in, and I went, oh no, for a couple of them. But I'm not smart enough to go, oh no, for sure. Did you find?
Yeah,
I'm trying to find it.
because she mixed bleach and ammonia.
can't
That
find
would kill you.
What was it called? I don't know how to. It's in French.
Mixing-
Mixing potion song.
Yeah.
It's French. I don't know how to find.
Hibernate.